Okay, so we're going to pick up where we. Where's the room so empty? What's going on? The last lecture was almost full. But anyway, so we're going to pick up roughly where we were last time. These are the cities I used in the third lecture last time, so the cities are going to be different. I assume no one's going to be really bothered by that. And I got one more setup thing I forgot. Delete this. So let's finish writing our tests, and we'll hopefully find a few reasons to use the debugger. Today on the schedule, it's listed as a debugger day, debugger 2. I've been mixing the debugger on Wednesday, and today we'll just kind of do testing and debugging simultaneously. And we'll find, hopefully I'll make some mistakes, and we can find an excuse to run the debugger. I made some mistakes last lecture and got some good debugger stuff, so we'll get some debugger in today. And we got a little bit in on Wednesday. So just to recap where we were, what we were doing is we wrote this countries parsing method, which is reading a file with city data in this format. We have the country, the name of the city, the region, population, latitude, longitude. And we wrote this method to get all of that information in a hash map, mapping the country code, that 2-digit country code, to an array list of all the cities in that country. Or are the seats empty because I had the lecture question up? People did the question and left. I wonder if that's what happened. I guess I can't do that. And we returned that hash map with all of that information. We also wrote this filter cities method, which was checking for cities, countries with 3 or fewer cities, and then printing that information to the screen, and that helped us generate our test file with complete countries. We have 2 complete countries, one with 2 cities and one with 1 city, from the full data set. Then we started writing our test case. We're calling our load countries method with a test file, that small file that we generated. And then we manually created our hash map of the expected output. So we manually put in all of this information, and now we're ready to start testing. And I think we got to just the line of comparing the sizes of these hash maps last time, and then we want to start testing. So whenever we have 2 data structures that we want to test, the first thing we're always doing is, I shouldn't say always, but the first thing we want to do is make sure that the expected data structure is the right size. So I'm going to assert equals the expected dot size and the actual dot size. The autocomplete was blocking the view too much, so I'm doing this without autocomplete today. We'll see if I can remember everything. We're going to make sure that actual is the right size before we start doing anything else. And what we want to do is write some generic code. Our goal is to write generic code that makes sure actual and expected have all of the same data contained in them. So we want to check for all the right data. And for test 7, and for this example here, sometimes order matters and sometimes order doesn't matter. At the top level, we have a hash map. And the order isn't even preserved in a hash map. So order can't matter in the hash map itself. So that won't matter. But when we get to the array list of cities, I don't think I wrote it anywhere in the example so far, but the array list of cities should be in the order in which those cities appear in the data. This parallels test 7, except we don't have a hash map. But the top array list, the order doesn't matter. But inside the songs, the linked list of ratings, the order does matter. It has to be the order in which they appear in the file, which matches what we did before with that array list. You can use your same testing code before that checks 2 linked lists for all the right values, specifically for ratings. We already have that code. So you can use that same code. If the order didn't matter, you'd have to throw that code away and start from scratch, and it's just a lot of tedium that I don't want to make you go through. So sometimes the order will matter, sometimes it doesn't. Be careful, pay attention to that in task 7. If the order doesn't matter, you have to accept any order If the order does matter, you just check to make sure it has those values in that order. So for the hash map, order doesn't matter. We're just going to check if the value exists in the hash map. So for string country in expected dot key set, we're going to assert that that country is in the expected set. Assert true actual dot contains key country. So we're going to make sure that key's in there. So this right here is effectively going to make sure that the actual output, that hash map, contains every single country that we are expecting. So if they're the same size, if actual and expected are the same size, in this case that means actual has 2 key value pairs, and we're going to iterate through both of the key value pairs we expect and make sure that each of those keys do exist in the returned hash map. So if that's true, if they're the same size and all the keys exist that we expect exist in actual, that means they must have the exact same key sets. Specifically, since keys can't have duplicates, there's no extra checks that we have to do for duplicates. We know that these 2 hash maps have all identical keys to each other. And then for each country, the next thing we can do is get the 2 array lists of cities from these hash maps. Actual cities equals actual.get country. Oh, wrong button. And then same for expected. So we're going to get the 2 array lists of cities, and we have to check to see if each of these countries in the actual and expected have the same exact cities. That's our next goal. Again, we have 2 data structures that we're comparing. So first thing we want to do, assert equals expected cities.size actual cities.size. Do these 2 countries have the same number of cities is the next thing we want to check. If they do, we're ready to move through all of those. Without autocomplete, I can't do that. Int I equals 0. We're ready to move through each of the cities. By iterating over the indices of the expected cities. Now this is maybe just a me thing, but in this specific case, but in general this is more useful. Whenever I'm accessing something that needs to be right, it's worded weird, I'm always going to go, when I have a choice between going to my expected values or my actual values, I'm always going to my expected values, in this case to grab the size of the array list. Now, it doesn't quite matter in this example because I just asserted that their sizes are equal. So whether I do expected or actual here doesn't truly matter in this case, for this test case. But I'm always in the habit of always going to my expected cities because I have full control over my expected value. I created it manually. I did everything by hand. I know that that's right. If I go to actual and try to get the size of that, something might go wrong. That's a really weird thing. Something weird might happen with that. Specifically, more to the point, if I don't have this check, maybe you forget to do your size check, and then you have actual cities.size. Well, what if the method always returns an empty array list? As long as they have a hash map with the right number of values, and all the cities are just completely empty, this is going to be 0. The loop's never going to run. The rest of our checks never run. And then we're going to say, yep, that's passing code. So we don't want to rely on any features of actual cities or the actual output that we got from the method because we have no idea what it is. It could be anything. Our test case's goal is to make sure that it is the actual right thing. We can't make any assumptions about it before then. For that matter, we should actually have an assert, not null. We can't even assume that it's null, not null, so we probably should have this, realistically. We're going to make sure that the returned output isn't null, because we can't even assume that it's not null. Can't make any assumption about it at all. So I'm always going to go to my expected when I need something to be right. I need the size to be right, because if that size happens to be 0, and I'm not actually checking things, things could go wrong. Unless I expect it to be 0. In that case, expected cities, that size will return 0. And then we'll grab the two cities. Expected city equals expected cities dot get of I. Now this is a safe operation. I asserted these two array lists are the same size, and then we're iterating over the indices of the expected cities. So that means expected cities and actual cities should have a value at index I. I shouldn't get an index out of bounds with this. And then I want to compare the cities. So at this point, and you've seen this before, at this point I want to start writing a helper method that's going to compare two cities. It's something I'm going to do multiple times throughout these tests. So when I compare these two cities, I'm not just going to compare them inline like this. I'm going to go write myself a helper method. We've seen compare doubles, we've seen compare songs, compare ratings, compare linked lists of songs. We've seen a lot of these things already. So hopefully you're getting used to this and embracing the glory of helper methods. So private void compare cities takes in expected, takes in actual, and we're going to have our asserts here. Assert equals expected dot get country, actual dot get country. And the reason to do this is because it's better organization. It's easier to reason about our code. We'll come back and finish that. But it's easier to generalize our test cases and make them a lot easier to work with. And our ultimate goal here, my goal whenever I'm writing test cases, is I want it as easy as possible to add another test case. When I want to redo another test case, I want it super easy, only the bare minimum of what I actually have to have for that test case. That's my goal. So for this, we're building our expected hash map of string to array list of cities. We're getting our actual, and we want to compare those two data structures. And what I still see, from anyone who's new to testing, what I still see in office hours, though, is testing the actual manually, getting actual here and doing something like assert true actual dot contains key SC, or even skipping that and just saying actual dot get SC dot get of 0 dot get name equals Victoria. And then actual dot get SC dot get 1 dot get region equals 08. And going through each value like that, or even less than that, some students will just check the sizes of the two hash maps, and they'll check like the name of the first city in one of the array lists, and then just say, yep, done. And then they wonder why they don't get the incorrect solutions in Autolab. What we want to do is make sure these two data structures contain all of the same values and no extra values. They should be containing all of the exact same information between expected and actual. And the best way to do that is going through the data structures generically and just checking absolutely everything in these two things. So we're going to check the country. And if you have things set up really well, my opinion at least, if you have things set up really well, certain parts of writing your code are actually going to be boring. It's going to be so non-challenging because you have a good structure, that'll get boring, and this is one of those cases. I'm just going to go through all of the instance variables. Let's see, get region, get name, get population. Whereas doing this part, if you're hard coding things, if you're not writing generic code and helper methods, this part can be really tedious and a little bit mentally taxing, trying to keep everything straight. Like remembering what key in the hash map you're working with, remembering what index of the array list you're working with. It can get difficult to manage just mentally keeping track of everything, and also very prone to simple mistakes, simple typos. One little typo is going to blow up your whole test case. Get latitude with a capital L. And get longitude. But with things set up nice, I'm still making typos, but I'm making the kind of typos that the compiler can catch for me, not the kind of typos that are never going to get caught until you submit to Autolab. And I'm seeing this, I just saw this the other day. A student had code that looked like this, well, not exactly like this, but like this line. We started using assert equals. We had Paul and I and Matt Hertz, we had a debate over what we should be using in the course, and we ended up going with, okay, let's show them assert equals, where we were just going to show assert true all semester, and then have you actually do your own comparisons manually to compare things, specifically with doubles. So with these two double values, I see code like this, and it bugs me because I'm like, if we were just doing assert true still, we wouldn't have this issue. If you're using assert equals, you still have to do that epsilon stuff. You still have to allow tolerance. You can't assert if two doubles are equal. You should never be doing that, because we're going to have truncation errors, and those truncation errors are going to make you have a bad day at some point in your career. I know because I've done it before. I was using equal on doubles, and I had a several-hour debug session trying to figure out what the hell was going wrong, and it was because I was using equal on doubles. You need your tolerance. If you're using assert equals, give it the tolerance. This is the epsilon when we were comparing doubles manually. This says, check if these two doubles are within 0.001 of each other. So we want some sort of tolerance here. That's going to ignore the truncation errors. Then we have our method that compares two cities. And it's checking all of the values. Some students still like to shortcut things and just check, like if the name of a song is the right thing, then everything must be right. But what if code has one mistake with just the title, or with just the ID, or with just one of the ratings in the ratings list? You have to check everything. And I know it can be daunting sometimes, but that's what testing is. We don't want any bugs, so we're going to check for every bug. It's the only way to not have bugs. Just make sure none of them are there. So we have our method. We're checking cities. We're going through the hash map. We're going through the array list. And we can run this test. See if we pass. Yeah, we pass. And what I like, I've done this in lecture a few times, I really recommend that you all get in this habit, especially outside of this class when you move beyond 116, is seeing your test fail. Change something with your code to make sure it's broken, and then see your test fail. So if I change this region, I'm just going to grab the wrong value out of the file and make sure that my test fails. Who thinks this test is going to fail when we break our code? Some of you? All right. I did sneak that one in there then. Our test didn't catch that. So we want to make sure our test is actually testing what we're expecting it to be testing. Now in CSE 116, this is what Autolab is doing for you with the incorrect solutions. So that's why I say beyond this course. Get in this habit by the end of this course. Is I broke my code, I ran my test to make sure that my test is catching that specific bug, which is effectively an incorrect solution. I just made my solution an incorrect solution. I'm running my code to make sure my tests don't pass this code, because this code is wrong. The fact that my test passed this code means that my test does not test for this bug. If I break things, -1's a bad idea. 9's a bad idea. I don't want index out of bounds errors. I don't want parsing errors. Let's just flip these around. And let's do the region is always an empty string. Oh, actually did fail that one. Size of the array list. Wait. Size of the dictionary. Actually did break it there. Oh, because I broke the country. Okay, well that's good. We did find one bug at least. All right, so we did find one bug. If the country is wrong, it's going to catch that. But we're not catching other bugs. Let's run this again to watch it pass again. I expected that one to pass. I see what happened there though. So we broke this code quite a lot. So each incorrect solution in Autolab is meant to be one of the ways of breaking the code and then making sure the test is actually testing for that. Because if you have potential bugs that can exist in the code that your tests aren't catching, there's an incorrect solution that has that bug and your test doesn't test it, then your code might have that bug. You'll never know because your tests pass. You'll go to the project manager and say, hey, all my tests pass. But if your tests are passing known bugs, you can have those bugs. Then you release to your customers find those bugs, and then nobody's happy after that. So we want to make sure our tests are actually testing things. This is my reason to use the debugger. So let's go through the debugger and find out why this is passing. We'll go through line by line. Usually if we have an idea of where the bug might be, we'll set a breakpoint where we expect the bug to be. Here we have no idea. The test is just passing when it shouldn't be with completely broken code. So let's just set a breakpoint somewhere near the top of the test. I'm sure all of setting up the hash map, the expected value is fine. But let's go right here and step through this code to find out what happened here. Run the debugger. It's going to stop when it gets to the first breakpoint. And by the way, I've said this before again too, but I'm seeing it in office hours a lot. A lot of my office hour visits that I have, I just say, what did the debugger say, and then help the student walk through the debugger. And when we go through the debugger, they usually find their mistake, and I might help them like how to run the debugger. That's usually what I'm doing. And they'll find their own mistake by running it. And I think a lot of office hour questions, like if you just run the debugger and do what we're about to do here, you'll see a lot of your mistakes that you won't need Piazza Post, you won't need office hours. The debugger is a very powerful tool. Again, a tool that I didn't learn until too late in my career. I made the mistake of not running the debugger as well. But it can really help. So let's just step through the debugger, get another tutorial on how this thing works, because I think some of you all forgot. We only did it one lecture a long time ago, and relearn how these buttons work. So I'm going to step through the code with this step into for the most part. That's like my default mode. I'm going to step into the code. But sometimes it's going to get me into a method that I don't care about. Like right here, I got into the assert equals method right away. So when I get into a method that I don't care about, I'm going to click this step out button. That's going to run the debugger until the end of the current stack frame. So it's going to run until the end of this assert equals stack frame, and then resume execution. This isn't a go back button. You can't go back in the debugger. If you want to go back, you just have to restart the whole thing. I would click the rerun button and go back to my breakpoint the first time and then start going through. I'm going to step out here, get into my loop. So the country, I'm looking at SC, my expected hash map, actual hash map. Things are looking good here, until we go into the values. The cities are going to be all jacked up because we have broken code right now. We're going to make sure that this country, the actual contains the key SC. It does. We just looked at it. So I'm going to click step over. That's going to skip the next line of code, any stack frames that would have been entered with the next line of code. So I'm skipping over the assert true. Contains key it wouldn't go into anyway because that's Java. I think assert true and assert equals it's going into because that's an external library, so it's not part of Java itself, so it's going into those ones. But I don't want to go into those. We'll skip these next 2 lines. We're just pulling the cities, the array lists, not the cities. And we have expected cities and actual cities. We have values in these array lists. We'll check the size. We just looked at the size. They're both 1, so we expect this one to be good. Then we're going to iterate over the indices of the expected cities.size. I want to go into this loop. So my I is 1. I'm going to get my expected city and my actual city. And that's it. So what I miss here? We can go through the loop. We're going to get to the next country. Step out of that because I got in a stack frame I don't want to be in. We're going to get into the next country. We're going to iterate over these 2 array lists. Make sure these 2 array lists have the same values. They clearly don't. Very much different values in these cities. Get the expected city. Get the actual city, and we're back at the top of the loop. We're at the end of that loop. We're at the end of the test, and we never failed this incorrect solution. Can you explain why when you get the size of the actual, it is equal to the size of the expected when the actual will be to whole file and the expected is only a small portion of it? Because we're using this test file right now. So we ran the filter countries method before to get some small countries with only a few cities in them, and then created this new test file, and that's the one that we're reading in this test. So we generated a test file with a smaller data set to make testing more manageable. If we're testing with the whole data set, we would never be able to write a test like this. I mean, we could, but generating our expected hash map, the way we're building it here it would take forever. We would have to use code to generate that, to get it done in any reasonable amount of time. And we're in this situation where we're using code to test code, which gets awkward. If I had to do that, like if I was working somewhere where they said, you have to have this test case, what I would actually do, and I didn't mention this in Wednesday's lecture. It was on the lecture question, but I think the lecture question was straightforward enough that you could get it without hearing me say this part. But what I like to do is go into a spreadsheet, open the CSV file, specifically CSV files. Go into CSV, open the CSV file in a spreadsheet, and then use the spreadsheet to generate my test cases. It makes it a lot easier to work with the data, and what I would do in this specific case is have my spreadsheet set up to write this code, especially the new city lines. I would have a column in my spreadsheet which took all of the values from the CSV file and printed it out in this way, so I could just cut and paste from my spreadsheet and have all my test cases there. That's what I would actually end up doing. The advantage of that is you don't have code testing code. You're still using a tool to help you generate your test cases in the spreadsheet itself, but that tool isn't your code. It isn't your Java code specifically. So we have 2 different methods of generating both of the actual output, which is your code, and the expected output using Excel. So if you use your code to test your code, if you wrote Java code to generate your test cases, you have your code testing your code, which it's very easy to make the same mistake in both, especially if you're cut and pasting the code, like flat out, you have the same mistakes in both. I see students do that all the time. We restructured the assignments to avoid that a little more. There were certain spots we were putting students in where it was just really tough to generate the test cases, and they ended up kind of doing that by default. But if you're using your code to generate your test cases, you make the same mistake twice, you didn't test anything. But if you're using like a spreadsheet or any external tool to generate your expected output, and then your actual is your code, it's a lot harder to make the same mistake twice. You make the mistake in your code and in the spreadsheet, a lot tougher to do. A lot tougher to have exactly the same bugs in both. So it can help generate test cases. I don't have autocomplete. No, it was compare. So the mistake, I assume most of you saw it by now. The mistake is we never called our method. We wrote all that code to test cities. We wrote our helper method. We never called the damn thing. So we're going to call it. By running the debugger, we saw that we never even got to those asserts. We never got into that method. Even, well, let's get rid of this, actually. Let's go back to the way we were. Maybe we suspect that there's a problem with the asserts. Let's run our debugger. It's going to stop the first time that it hits a breakpoint. We're going to click resume so it runs until we hit the next breakpoint. And we get all the way to the end of the test. We get our test results without ever hitting the other breakpoint. So that's another way we would determine, oh, we wrote that code, but it's never even being executed. So we want to actually call our code. We run our test. The test fails. Now we're actually seeing our test get rid of an incorrect solution. And we could go through, it was this line, it was the region that was wrong, it was supposed to be 08, but it was actually empty string. And we can, debug further with that. But in this case, we know that we just completely broke our code here. Let's fix our code. Run it again, and hopefully we pass this time, and we're actually checking things. And at this point, we got one test. That's it's a good start and all. But we still want to get to the point where we can write another test. I had to go a little further there. Where we can write another test. I want another test here. And here's where we would, have cities with more, or countries with more cities and more thorough test case. Since it's lecture, I don't want to have you sit here and watch me copy and paste city data over and over. So I'm going to create another test file. And I'll use the same file, but I'll just delete one of the countries. So we just have a file, the simplest test case we can have for this objective, except maybe no data at all, I guess. But just one country with only one city in it. And we want a test case for this. So we want this set up to be able to easily do this. We'll set up test 2. We'll get rid of this other country. And if we were completely changing the data, our task would be updating these cities, updating the countries with the actual data. We do want to just change the file name and change the expected output. But we can't quite do that because we have a bunch more code here that we want to, that we could just cut and paste like we did. But that gets bad. I don't have another way to explain it. To the point where even IntelliJ is like, hey, you got a bunch of cut and pasted code here. What's up with all this duplicate code you have? It's generally a bad idea. IntelliJ even points it out and says, hey, this is a bad idea. We usually don't want duplicate code. If you have a big chunk of code that you have even 2 times in your project, it's a good indication that you want to grab all that code and throw it in a helper method. So let's do exactly that. So let's have private void compare countries, which is going to take 2. I want to cut and paste this because I don't want to type all that again. That was actual expected. I'm going to name them the same things that I had before, so I can just reuse all of this code and just put it in a helper method instead of in the test case itself. So everything that's common across test cases, I'm going to throw that in helper methods. And now when I define a test case, everything that I do in the test case is just related to that test case. Update the file name, update the data, that's it. And I can't get any less than that because they're different test cases. Those things are going to be different for each test cases. And then add my compare countries. Expected actual. expected actual. Run our tests. We just built another test case. The comment is incorrect. And they're both passing. So generating another test case, create a new file, update the file name, update the expected, click run. That's what we want to get to with test cases. All this code that we wrote, we never touch that again. And whenever we have to compare hash maps of countries to array lists of cities, we just add a new test case. So when I submit to Autolab, and Autolab is like, oh, all these incorrect solutions, you got to add more testing to get rid of these things. I'm not cut and pasting 50 lines of code and manually going through a whole bunch of stuff to update that. I'm doing it the minimal amount possible, which is the minimal amount of taxation on my brain. I don't have to really dig deep and really think about it too hard because I have a nice structure set up that I don't have to really work at it too much. It's even saying that these 5 lines, that duplication, IntelliJ, I think I'll live with that one. Any questions on this? Who wants to write another test? Let me copy this much. All right, let's test a method that's going to use the entire data set. So if we usually do want to do some testing that uses the whole data set. With the previous method, the method returned all of the data in the file, so it wasn't really feasible to use the full file. But if we have a different method that does make it feasible, we can use the entire file. So let's use the whole file to write a method that computes the population of a country. So I'll pick what country we want, but not yet. Int population equals countries example dot country population, I suppose, file name country. Int expected equals some number, and then assert equals expected population. And then we want to write this method, which right now I'm just going to stub it out like you did for test 4. Public static int country population string file name string country. We won't get to that sorted population method, but and we'll return 0. So we have a stubbed out method. We can run our tests to watch it fail. Actually, it'll pass here, right? We'll watch it pass because I was expecting 0 and my method always returns 0, so it just happens to pass there. And we want to get a test case for this. And this is where we'll see the benefit. 3's fine. This is where we'll see the benefit of our filter cities method a little bit more. So we're going to run our filter cities method again to print out cities, and I changed the code a little bit in the last lecture. I forgot to revert it, but to be exactly 3 cities in a country. We'll run this method. Oops. We'll get our cities with countries with exactly 3 cities. Let's pick on SH this time and use this as our test case. So with SH, again, we're giving this the entire cities.csv with tens of thousands of cities in it, but we're going to make sure we choose a small city because guess what we have to do? Sum up these populations. So I'm going to look at the populations of these 3 cities, and with 3, it's not that big of a deal for me to open up my calculator, sum these up. Oops, of course I did it wrong. It is hard for me. That's wrong. That's wrong. It's very hard for me, apparently. 538, 637. And get the population of this country. This is one of the objectives. This used to be an objective back in the past. This is where students would write their method, run their code on just any country, and then use that as their test case, and then wonder why Autolab said their code's broken. It's because they used their code to generate test cases for their code. They had the same bug in both places, of course. But I didn't know what I expected them to do, because this is what I would expect them to do, and they just didn't do that. But now we're showing you more explicitly how to do these things. So that's my test case. Let's write the method. And if we want to write tests that use larger cities, this especially is where I would go to a spreadsheet. I would select a country, filter by a country. It could have as many cities as it wants, and just do a equals sum of all these cells with all the populations, and then use that as my test case. That's another thing I expected the students to do, but we restructured because it wasn't that fair, to be honest. So we have the file name, and this is one thing that I hope you are all used to, is calling our other methods. This is something we struggle with getting students to do in 115. I think in 116 we're good on this. But I don't want to go to this file, do our files.pass.get, read all lines I missed in there. I don't want to do that. We already have a method that's going to read all the lines of the file and return all of that information in, I don't feel like typing the whole thing, in a hash map that has all the data from the file. I'm just going to call that method, and I ain't going to the file at all. I'm just going to call the method that I already wrote and let that method do the work for me. So I can just think about calculating the population of a country when I'm running this method. Then I'll check. If this were a programming task, I would say read the file, check, return the sum of the population of all the cities in the given country, and if the country doesn't exist in the file, return 0. It would be worded something like that. So first thing I want to do is check if actual.contains key. Does this country even exist in the data that I'm given? Because I can't make any assumptions about the data, especially when we're generating our own test files. This test file could have any information ever. It could just be made up information. It could be fake countries. It could be countries with country codes that don't have 2 characters. I can't make any assumptions about the data at all. So I'm going to check if this country exists. Hell, I can't make any assumptions about the country either, because it's a parameter. So I'm going to check if the country exists. If it doesn't, I'll return 0. If it does, I'm going to calculate the population of this country. So for city in this country, I shouldn't have named this actual, .get country, which is a safe operation because I just checked that it contains this key, so I can get the value at that key and iterate over the cities in this array list for this country. Let's initialize some population equals 0. Population plus equals city dot get population. Oops, I ran country's example. Let's go to our tests. We're happy with our code. Go to our tests. And we're not happy with our code. Assertion error. We expected this. We got 0. So here's another case where I want to run the debugger. Hey, we got a debugger example. Actually, this one we're not going to get through, though. So I'm going to set the debugger. Set it right here, just for the sake of time in lecture. So population 271, population 809, population 1446. This looks good. But then we're going to return 0. We never return population. We never return the population, so let's return the population right after the loop. We will get through this, but I kind of shortcutted it instead of stepping through. Then we'll see our test. Pass. Yay. All right. The lecture question today, I left it up before lecture, so some of y'all already saw this. We got 5 minutes to do it instead of 2. Go to ubratingsongs.com. This is also the rating site that's linked from the Task 7 handout. And rate or add at least one song. If there's something in the logs with your UBIT attached to it, you'll get credit for the lecture question. And don't submit to the actual Autolab question. So we want all kinds of data for us to work with in Task 7 and Task 8. So this is our incentive to get lots of data in there.